Welcome back. So, we talked about some basics of volcanoes, where they're at. So let's talk about the different types and the different types of eruptions that we can get at volcanoes. So, volcanoes vary greatly. Size, shape, composition, the magma that they're kind of bringing forth to the surface. But when we're talking about the differences, we look at the viscosity, how flowy it is, and volatile content, how much gas is trapped in there. Those are still the primary controls of volcano types and eruption explosiveness. Going back to this, though this was back in the first section, again, the higher the viscosity, the higher the volatile content, the higher the explosivity, which is really the determining factor of creating different volcanoes and their different explosivity. And all of that is tied to silica content, how little or how much it has. All right. So when we're talking about these different volcanoes and different eruption types, it's all due to difference of viscosity and volatile content, which you can tie it back to silica. So what you see here are 6 different ways in which volcanoes can erupt. These are the 6 different types of eruptions that can occur. We have Icelandic eruptions, Hawaiian eruptions, Strombolian eruptions, Volcanian eruptions, Palaean eruptions, and Planian eruptions. Now these are typical of certain different types of volcanoes. Icelandic eruptions usually happen at fissure or rift volcanoes. Hawaiian eruptions are typical of shield volcanoes. Strombolian eruptions, cinder cones are common volcano where we see this type. And then stratovolcanoes might exhibit Volcanian, Palaean, or Planian eruption types. So, in order of increasing degree of explosiveness, Icelandic types of eruptions, least explosive. You can get a lot of lava flowing out of them, but it's not like a big explosion that occurs when these volcanoes erupt. So from least to greatest, Icelandic, Hawaiian, Strombolian, Volcanian, Palaean, Palaean, and Plinian. Be careful with those last two. Strombolian, named after the area in Italy, Stromboli, in which this was kind of first seen. Volcanian, the Vulcan, the Roman god, some god of the underworld. Palaean, as in the goddess Pele, and then Plinian, named after Pliny the Elder, who first described the eruption of Mount Vesuvius in Pompeii. Now, I've included and painstakingly gone through YouTube to find a bunch of different videos to show you different types of eruptions and the locations in which you might see some of these. So please, it is required. Make sure you're watching all of these videos. They can be pretty short. So when we're talking about how least explosive to most explosive an eruption is, that's something that's measured on something called the Volcanic Explosivity Index, or VEI. It's a relative measure of the explosiveness of volcanic eruptions. Like relative, comparing this to that. It's not necessarily a hard measurement per se, but compared to this other eruption, this one was much worse. This one was not as worse. This one was gentle. This one was mega colossal. So you're kind of just giving it a relative feel. It is dependent on how much volcanic material is thrown out and to what height, how long the eruption lasts, but again, also some of those relative qualitative things, gentle, huge, ginormous, gemundous eruption, all used to kind of determine the explosivity value, which is ranked from 0 to 8. It's a logarithmic scale, similar to the Richter scale, in that from a 6 to a 7 on the Richter scale, it wasn't just kind of one step, it was multiplicative. Same with VEI, Volcanic Explosivity Index. An increase of 1 on the scale indicates an eruption that is 10 times as powerful. So if you go from a 4 to a 5 on the VEI, that 5 is 10 times more powerful an eruption than a 4. But if you go from a 4 to a 6, that's 4 to 5, that's 10. 5 to 6 times 10, that's 100. 10 times 10, 100 times more explosive. So just to give you some references as far as volume of material erupted out of volcanoes on this scale, here's the VEI compared to the amount of volume that you might see. So Icelandic, Hawaiian eruptions are kind of the 0 to 1 scale. 1 to 2 Strombolian, 2 to 3 Vulcanian, 3 to 4 Palaean, 4 all the way up to maybe about a 7 is Plinian. And this isn't technically one of those 6, but super volcanic eruptions are kind of on that 8 scale. More on super volcanoes a little bit later. What just happened? There we go. So how many times have these types of eruptions occurred in the past? Well, low, many. And then you can see the more explosive, the more intense an eruption is, the less times it has happened in the last 10,000 years. So you can see when we're getting up into like Mount St. Helens, which erupted in 1980. That was a Plinian eruption. But, that's around 166 of those happen every 10,000 years. So about 1 every 100, 1 every 50 years or so. When you get above that, it gets pretty rare. There's been no super volcanic eruptions the past 10,000 years. So, lowest on this scale, the Icelandic Hawaiian style eruptions. Well, what those types of eruptions are more typified at are something called shield volcanoes or fissure volcanoes. The magma produced, and thus the lava, magma below ground, lava above ground, is very basaltic in nature, meaning it has a low viscosity, it's very flowy, very runny, so you very non-explosive eruptions. Shield volcanoes that can be formed are the largest volcanoes in the world as far as diameter, measuring them across. They can be up to over 100 miles wide. This very thin lava that comes out of it kind of flows in all directions to create this kind of circular, huge, shield-shaped structure on the surface of the Earth. And these types of volcanoes are much wider than they are tall. Again, they can be hundreds of miles wide and maybe a few miles tall. Fissures are about a few meters wide, but they can be many kilometers, many miles long. Again, basaltic magma and lava coming out. So instead of like a hole where the magma's coming out, it's just a big long crack where the magma's kind of coming out like in a couple directions, these fissures. Both of these are kind of common at hot spots in the oceanic crust, as well as divergent boundaries or continental rifts. The Hawaiian Islands, shield volcanoes. Iceland, get these fissure volcanoes. The East African Rift, this divergent boundary on the continent, fissure volcano. And that's these Icelandic eruptions, Hawaiian eruptions. So again, the fusion of molten basaltic lava, very runny, low viscosity, very runny, non-explosive, flows out of these long cracks or flows out of these kind of shield volcanoes. All right. You can see the cross sections of shield volcanoes, these many layers of volcanic material building up over time, and same with fissure eruptions. So here's an example of an Icelandic eruption. You see this nice long fissure, this linear break in the ground in which lava is coming out. Now these fountains of lava could be 100 plus feet high, but it's not very explosive. All right, I mean, you don't want to stand there, you don't want to jump in, but they erupt, this stuff gets shot out and it kind of flows out. So it's very gentle. It's very gentle. So the reason we call them Icelandic eruptions are these are typical type eruptions in Iceland. Iceland sits on a hotspot and a divergent boundary. So the country, island of Iceland, is literally being ripped apart. This is looking right down the center of that part where it's getting ripped apart. So part of this, part of Iceland is on the Eurasian plate. The other part of Iceland is on the North American plate. It's literally getting ripped apart. So creating these long fissures. This is an older one. You can see there's no lava coming out of here. Hawaiian eruptions, again, you might get a big fountain of lava, but then the lava flow that comes out of it, it's very gentle. Again, you don't want to jump in it. It can create forest fires, it can burn structures, but it's not very hazardous to life. You can get out of the way. You know when a lava flow is coming, you just get out of the way. So some examples in Hawaii, Mauna Loa, so is a shield volcano, again, very wide, much wider than it is tall. Kilauea, again, much wider than it is tall, but you can see this is a large area in which there's magma below. As it erupts, it kind of spills out in all directions. So those are very low explosive Icelandic and Hawaiian style eruptions from shield volcanoes or fissures. Next, kind of increasing in explosivity, let's talk about cinder cone volcanoes. These are very much a cone shaped. They're very stereotypical. Like if you told a kid to draw a volcano, this is probably what they would draw. Kind of a very cone shape with a circle on the top. It's built up from an accumulation of tephra. Tephra is just these small ejected volcanic rock fragments, kind of little spittles of lava that kind of get shot out in a strombolian eruption. Cool very quickly. They cool by the time they hit the ground, so it kind of builds up these piles of these loose little pieces of tephra called cinders to create a cinder cone volcano. These are common around other larger volcanoes, like stratovolcanoes. They can be found near normal faults, sometimes along cracks and fissures as well. A lot of examples, and even here in Arizona, SP crater in Arizona, Paracutin in Mexico, Sunset crater also in Arizona. But what's typical of these types of eruptions are strombolian eruptions at cinder cone volcanoes. Moderate bursts of expanding gas that eject clots, little pieces of glowing lava, incandescent lava, in cyclical or nearly continuous small eruptions. So it's kind of so a bunch of little spittle coming out. You know, sometimes when you're talking a lot or talking fast, a little bit of spit comes out. Same thing here. So a little bit more sticky lava, a little bit higher viscosity, but oftentimes still basaltic in nature. So it can be a little sticky with some gas kind of content, and that increase in gas content will cause this kind of smaller little explosions to happen. So here's a picture of a strombolian eruption. Again, looks really cool, you know, the stuff coming out, but really not too much other than that. But these cones can build up in a matter of weeks or days with all this little material that kind of just litters the ground. So here is SP Crater in Arizona. This is just north of Flagstaff. You can drive here. You can actually park right at the bottom here, climb up this trail, and then climb to the top. So since these cinder cone volcanoes are made of loose cinders that kind of have fallen, they're kind of hard to climb. They're very loose, sharp, little jagged rocks, so it can be kind of hard to climb. This is an extinct volcano. It will not do any more volcano things, so it is safe to climb. Here's another in Mexico. Again, very stereotypical cone shape with a little circle on the top. This actually erupted in the 1950s, so less than 100 years ago. You know, there's footage of this kind of being created, and as it not only created this cinder cone, but kind of as it flowed out, it actually buried a town. And Sunset Crater here in Arizona as well. It's only about 5 miles north of Flagstaff. You can actually visit this one. SP Crater is kind of off-road in the middle of a ranch. You can go there. It's a little weird to get to. This is a national monument. There's parking. There's shops. You cannot climb this one, but there are different paths and trails you can go out and look at the lava flows. It's a very interesting place, very otherworldly. It's odd to think about, you know, volcanoes in Arizona, but we got plenty of them. This is a cool one to visit. Cinder cone volcano. Sunset Crater. All right, let's go ahead and pause here. When we come back, we'll talk about those different eruption types tied mostly to composite volcanoes, or excuse me, stratovolcanoes, and then kind of the biggest of all, not even on the scale, but super volcanoes. I'll see you back here in just a minute.